This video shows examples of humanoid characters simulated using Xarkin technology. This first example is a standard-sized human performing a casual walk. The grid shown on the support surface is at 1 meter spacings. The original pattern for this motion is a standard mocap data file from CMU. The dimensions of the character have been modified a bit, estimated masses have been assigned, and the location data obtained from the mocap file has been enhanced with surface contact timing information. A given motion pattern is considered a request for the motion of the chosen character, as if a film or game artist had chosen it for the motion of the character in their project. This artistic request is processed through the physics simulator and modified under the control of the artist to produce a physically correct version of the motion. As for a real human character being motion captured, control of bodily motion is determined completely by the internal torques generated at each joint. The only external force is with the support surface. The output of the simulator is the location data for the elements of the character performing the corrected walk in the form of a new mocap file. The simulator can also emit full simulation data, including actuation torques for each degree of freedom at each joint, surface contact forces, and the forces on and linear and angular velocities of each bone segment in the skeleton. This is a sample of data from the simulator. This is the force on the left toe while it is in contact with the ground, shown here in graphical form. This is the torque data for the left ankle over the duration of one step cycle. The swing torque moves the toe up and down, and the rotation torque moves the toe from side to side. Torque magnitudes are small while the toe is not in contact with the ground. During contact, a large swing torque applies force down at the toe to support the character's weight, and the rotation torque applies a lateral force to the toe. This is a heel-toe walking gait, so the torques during the initial frames of the toe contact occur while the heel of the same foot is still in contact with the ground. During most of the toe contact with the ground, it is the only point of contact, and the final frames of toe contact coincide with the heel strike of the other foot, after which the toe leaves the ground and the torque magnitudes are again very small. The animation can be enhanced with an indication of the surface contact forces experienced by the character's feet as it walks. Here's the same walk request made for a 4 meter tall character. For this example, character dimensions were doubled, but masses were left the same. If the same flesh proportions had been applied to a character of twice the height, the character would be 8 times more massive, so this is a very skinny character. Again, the contact forces can be overlaid on the animation. And here's an example using a 1 meter tall character. This time element masses were halved. As well as allowing for arbitrary character design, another of the benefits of doing motion generation instead of motion capture is that we can choose environmental values like gravity. Here's our character walking in moon standard gravity instead of Earth normal gravity. The force of gravity on the moon is approximately 1/6 that of Earth. While the same style of walk can be executed by the character, the contact forces with the surface and all of the internal torques and forces are substantially smaller. In future videos, I'll examine gait analysis and manipulation techniques and apply them to a variety of humanoid and non-human characters. Thanks for watching.